So let's have a look at some of these examples. Number 1 says, find the exact value. Exact value, that should trigger, these are going to be about 30 degrees, 60 degrees, or 45 degrees, because they're our three angles that we're frequently asked about and required to give the answer in exact form, because they all have surds. The right angle triangles containing those angles all have a surd, so that's the 30-60 one, and the 1/1√2 for the 45. So remember that. So I'm thinking already this angle tan -135 has something to do with these, and it's clearly not the 30-60, it's got to be the 45. Let me first of all get established then where this -135 is. It's a negative angle. We're going to be going in a clockwise direction from here. So we're going around more than -90. We've gone around a -135. So clearly we're here. We still name the quadrants 1, 2, 3, and 4. We're in the third quadrant. The rule about ratios being positive stays the same. All ratios positive, all stations 2. Tan is positive in this quadrant. So I know that the tan of this negative angle is going to be a positive answer. Now, in this quadrant, according to our pattern that we've established, is that angles are actually named as 180 plus theta. So let me establish where this -135 is. Say it's about here, -135. It may be easier to start with to see how much past -90 you've gone. What is the size of the angle in here? That's the easier one to find and the first one to find, although it's ultimately not the one that is theta. But so let's establish that. So it's 45 degrees, isn't it? We've gone through another 45. Don't worry that it's a -45 at the moment. We'll just say we've gone through 45, which then means that this is my angle that I need. We know this is the angle that you need. So I can now see there's a connection between the angle -135 and the acute angle 45. And that's basically all I need to establish. We know tan in this quadrant is a positive, and it is nicely connected to the tan of 45, because if you scroll back, you'll see that our angle that we must identify and call theta is the angle here in this position. Okay, tan 45 is actually equal to 1. No problem. And no surd, for that matter. Okay, sine 240. So we're back to positive angles now. So we're going in the nice positive direction. And 240 again occurs down here, doesn't it? Because it's between 180 and 270 when we're going in the positive direction. What do we know about sine down here? We know that sine is a negative. So already we know that sine of 240 is going to be a negative. What is the acute angle, or the angle in this position here, that is required to get to 240? So you're working out the difference between 240 and 180, which you can see is 60. So it's negative the sine of 60. Now, we're expecting that because the instruction at the beginning of the question was exact. Sine of 60, go to your little triangle. 60 degrees is here, and the sign is root 3 on 2. It must be a negative because in the third quadrant, sine is always negative. Remember, all stations 2. The only one that's positive is tan. Moving on, cos 315. Where is the angle 315? So it's a positive angle going in the positive direction. We're down here. We're between 270 and 360. When we're there at 315, we must establish what this angle is. So we've come all the way around up to 315, but we must establish the size of that angle there. So 360 minus 315 takes us back to our 45. Now, in this quadrant, what do we know? All stations to central. We know that cos is positive in the fourth quadrant. So cos of any angle in the fourth quadrant will be positive, and the acute angle that we associate with 315 is 45. And the cos of 45, back to this triangle over here, is 1 on root 2. So they're fairly standard sorts of questions that you get. And another variation of question that you might also come across is here in example 2. And it says, if sine of theta is 4 on 7, and the tan of theta is less than 0. So the tan of theta is a negative. So theta, the sine is a positive number. The tan is a negative number. Find the exact value of cos theta and tan theta. The exact value of cos and tan. Now, we will identify exactly where theta is by thinking about the sine is positive and the tan is negative. So where does that occur? Well, it's not here because everything is positive here. The sine is positive here, and yes, the tan is a negative in this quadrant. Could theta be down here where sine is a positive? No, sine is not positive down here. And likewise, sine's not positive there. There is only this one quadrant where these two conditions hold true, that the sine is a positive and the tan is a negative. So what I know is I'm working in the second quadrant. Theta is definitely in the second quadrant. Now, we need to find the exact values of cos theta and tan theta. Well, we can draw a little right angle triangle. We're going to put theta in it. We know that the sine of theta is 4 on 7. We can use this right angle triangle and Pythagoras' theorem to find out the length of this side. So that's what we do. 7 squared is 49 and 4 squared is 16. So the length of this side is the square root of 33. I'll just sit that in there a little bit close. Whoops. 33. Now, cos of theta, we'll read directly from our little right angle triangle. Here's theta. Cos is adjacent. It's root 33 over hypotenuse, which is 7. But what do we know about the cos in the second quadrant? Cos in the second quadrant must be negative. And again, something I didn't actually point out in the beginning was these questions also say exact, which now we've got a different situation where exact means something else. So in this situation, it's not like we're being asked to find theta, so we're not thinking, oh, our answer is going to be 30, 60, 45. No, because we're not being asked to find theta, but we're being asked to find an exact value, and in that case, I'd get you to make the association now with Pythagoras' theorem and right-angled triangles. So see the exact, and you're not finding an angle, but you're finding a ratio, make the connection to a little right-angled triangle. And likewise, don't actually evaluate the square root. The other ratio we were asked for is tan of theta. And what do we know about tan in the second quadrant? We know that tan is the negative, and the tan of theta from our triangle would be opposite over adjacent. So it's this negative 4 on 33. Oops. And we don't need to rationalise the denominator. It's not really testing that. There's plenty of other things it's testing. You'll see that I've included the graphs. Now, you can use these graphs. Knowing this is sine, we've established that it's almost like this is quadrant 1, this is quadrant 2, this is quadrant 3, this is quadrant 4. And we said that the sine was positive in the first and second quadrant. Yep, you can see that by your graph. And sine is negative in the other two quadrants. And then you can also see how that relates to cosec. Cos, we said that, again, this is quadrant 1, this is quadrant 2, this is quadrant 3, this is quadrant 4. We know that cos is positive, and our graph is above the x-axis. It's in the positive y values. And we know it's positive in the first quadrant. Second quadrant, it was negative. Third quadrant, it's negative. And it wasn't until the fourth quadrant that cos became negative. And likewise with the tan, starting here, we've got tan is positive. First quadrant, second quadrant, third quadrant, fourth quadrant. And you can see that tan is positive again in the third quadrant. All I'm doing here with the graphs is reaffirming the pattern that we just established with the circle and talking about quadrants 1, 2, and 3. I'd also get you to fill this out. My video is running out of time, so I won't have time to do that. But please use the graphs to read off these values. And I'm going to actually get you to do exercise 4C. Definitely some questions out of that. And I'll just pause the video and find those. Could I get you to do in exercise 4C questions 1, 2, 3, 4, 5, and 6? And also 8, and then go on to 4D and 4E as is given there.